We've been looking at factoring problems like this for a couple videos here, and we call this factoring a trinomial. We have three terms here, and what we've been doing so far is looking for two numbers that multiply to 12, add 7. Okay. We start with the number 12, we look for the factors of 12, 1 times 12, 2 times 6, 3 times 4. All right. We look for the one that's going to add to 7. We make sure it works. 3 plus 4, 3 plus 4. And we've been saying, okay, well, that means the answer is x plus 3 and x plus 4. Okay, this is correct. This is all you ever have to do in these problems, as long as that coefficient in front of the x squared, that doesn't look so great, coefficient in front of the x squared is 1, right? Now, for this semester, anytime you see this, this is all you have to do. But as you move forward, you're going to see problems in future courses, perhaps where the coefficient in front of the x squared isn't just 1. And then we're going to have to learn how to deal with that. We're also going to learn a fourth technique, factoring by grouping, which is going to show us a different way to do this. Okay? We're going to start the problem the same way. Once we realize it's a trinomial with no greatest common factor, okay, we're still going to do this work over here, come up with the two numbers that multiply to 12, and then add to 7. Okay? Instead of just writing those two numbers in the blanks, what we're going to do is sort of show why that works. And we're going to start off by splitting this 7x up into 3x plus 4x using the 3 and the 4 we figured out. If you remember when I first introduced this, we multiplied x plus 3 times x plus 4. We combined the middle terms to get the 7x, and we said the goal was to try to split this 7x apart so that we could factor it. Okay? Now the rest of the stuff's going to come down as it was, x squared, right? This is a positive 3x. This 12 is going to come down to be positive 12. Okay, so to do this factoring by grouping, we're going to do exactly what factoring by grouping implies we're going to do. Group terms together. We're going to take the first two terms and we're going to take the second two terms and group them together. Once we group each of these two terms together, and my equal chain going here, that, we're going to look at what do the first two have in common. So let's look at these two terms, x squared plus 3x. They have a common factor of x, leaving behind an x plus 3. It's always a good idea when you do the GCF to, in your head, just kind of redistribute that term, make sure it works. Right? But we don't want to keep it cluttering up the paper. Right? What do these next two terms here have in common? Well, they have a plus 4x and a plus 12. They have a plus 4 in common, and that's going to leave us with an x plus 3. Okay. If we did this right, which I happen to do here, you should notice that what's in the parentheses here is in fact the same. If you have a problem that can be done with factoring by grouping, you will always have this situation. So if you get to this point and you don't see that, you either have to double check your GCF factoring, make sure you did that right. Otherwise, factoring by grouping won't work. Okay. Now, when we think about this, there's really one plus here, which has two terms here. Okay. What do these two terms have in common? They both have the x plus 3 in parentheses, right? So this thing that's underlined in red here becomes the common factor. We always pull the common factor out, right? And then what's left behind, this x and this plus 4, are going to be the two things left behind to create the x plus 4. Okay? So this is sort of a full method. We call this sometimes the AC method. And it's called the AC method because we label A, B, and C to be the coefficients of the x squared x and constant. Okay? But like I said before, this semester, all of the A's are going to be 1, which makes all these steps not really necessary, but it's not a bad idea to know how to do it for when it does become necessary. Right? So as long as you understand what I'm saying, as long as the coefficient of the x squared is 1, once you have these blanks filled out, you can just jump straight to the answer and fill them in. As soon as this A becomes something more than just 1, you can't just fill those numbers into the blanks. It gets more complicated. You have to use this full grouping technique. Okay, I'm going to do one more just so you can sort of see it a few times. Okay, we're going to factor x squared minus 4x minus 12. We're going to start with the same thing we always do. We need two numbers that multiply to negative 12, and those same two numbers are going to have to add negative 4. Okay? And we start with the 12. We'll worry about the negative in a minute. 1 times 12, I think we just did this, right? 2 times 6, and 3 times 4. Okay? Remember, in order to multiply to a negative, you have to have one positive and one negative. Right? That means that the two things are going to be subtracting 4, not adding to 4. So we're going to use the 2 and the 6. So I'll put a 2 and a 6 here. Right? But 2 plus 6 is 8. Obviously, I have to make one of these negative. The negative over here is going to cause the 6 to be negative. So I'll do 2 and a negative 6. Double check that these both work, and then you should be good to go. Again, you could just jump straight to the answer, x plus 2, x minus 6, and that would be fine. But since we're trying to show this new technique, I'm going to do this the other way. I'm going to use that 2 and negative 6. Remember to split up this negative 4. So this sort of shows the whole distributive property, the FOIL method, the box method in reverse. Split that minus 4x up into its two terms, plus 2 and minus 6. Okay? You could always look and see that if you were to put these back together, you'd have exactly what you started with, which means what you did was fine. Again, we're going to group and group. So that's called factoring by grouping. And then we're going to look for the GCF. What's common in this first group over here? Common factor of x. So I'm going to take the x out. I'm left behind with an x plus 2. What's common over here? Well, it looks like there's a 6 common, right? But there's also a negative here, right? And if I don't take the negative out, then I would be leaving the negative in the parentheses. There's no way things are going to match. So I'm going to take the negative 6 out. That's going to leave the x behind, so I have a good chance of matching. And it turns out I have an x plus 2. Now, a common mistake would be to have this x plus 2 first as an x minus 2. But hopefully, if you're in your head or even on paper, you're doing this multiplying to check your work, you hopefully would catch yourself and say, well, negative 6 times negative 2 is not negative 12. And then at that point, you go ahead and correct your answer. And the other thing you want to keep in mind is that if this is going to work, these better be the same anyway. Right? So there's a couple ways you could catch that mistake. If it happens, we all make mistakes. That's how we learn. But if we're looking out for them, we should be able to correct those. Okay. So now, once again, we have two terms, right? You have one term here and one term here. I'm going to erase that just so it doesn't keep the screen too cluttered. Okay. And now the common factor becomes that x plus 2, right? And what's left behind? Well, you've got an x and a minus 6 left behind. Okay. Again, we could have gone straight from here to there. Doesn't take that much more work. And as long as this x squared is 1, you can skip those steps, but in future courses when the x squared is not 1, you're going to have to do this work. So this is really just showing how the factoring by grouping technique works. On old problems we could do without factoring by grouping. What we're going to look at next is how to do factoring by grouping when we don't have any other option. Okay, so make sure you practice some of these. At least do a couple just so you know how it is, especially if you're planning on going into the next course and dealing with ones where a is not equal to 1. But otherwise, just kind of look it over a few times and we'll get into the factoring by grouping